Welcome to the deep dive. You're here, I'm guessing, because you want to really get a handle on important topics, but maybe without drowning in information overload.
That's the idea.
Today, we're diving into Alzheimer's disease. We're using info straight from the National Institute on aging the NIA to try and give you a clear, solid understanding of this, well, really critical health issue.
Exactly. We know time is precious, and Alzheimer's, it affects so many people, directly or indirectly. Our aim here is to pull out the key stuff from the NIA's resources, give you a real sense of what this brain disorder is all about, and maybe shed some light on why it happens the way it does.
Okay, let's jump right in then. Alzheimer's disease, fundamentally, it's a brain disorder, and it's tough because it slowly chips away at memory and thinking skills.
Gradually, yeah.
And eventually, unfortunately, it gets to a point where even doing simple everyday tasks is really hard.
And the scale of it, when you look at the NIA figures, it's pretty staggering.
Yeah.
They think over 6 million Americans, mostly people 65 plus, might have it.
Wow.
And it's not just, a common thing with aging. It's the 7th leading cause of death in the U.S.
7th.
Yeah. And the most common reason for dementia in older adults.
Okay. Dementia, that word comes up a lot. It's not actually a disease itself, though, is it? More like symptoms?
Precisely. Yeah. Think of dementia as like an umbrella term.
Okay.
It describes that decline in cognitive function, thinking, remembering, reasoning, and behavioral changes, too. And these changes get bad enough that they really mess with someone's daily life, their normal activities. It's also worth remembering, dementia isn't one size fits all. The severity can vary, quite a bit.
So Alzheimer's is one specific type of dementia, but there are others you mentioned. What else does the NIA talk about?
Yeah, the NIA mentions several others. There's Lewy body dementia that involves different protein deposits, not just the plaques and tangles of Alzheimer's. Often affects movement, can cause hallucinations.
Yeah.
Then you've got frontotemporal disorders. They hit personality, behavior, or language more up front.
Right.
And vascular dementia often tied to strokes or problems with blood flow in the brain. And actually, it's pretty common for people to have mixed dementia.
Ah, like a combination.
Exactly, like having both Alzheimer's changes and vascular damage in the brain at the same time.
Got it. Which brings us back to the name, Alzheimer's. Tell us about Dr. Alois Alzheimer. How did this all start?
Yeah, it goes back to 1906. Dr. Alzheimer, he made this, really crucial observation. He was looking at the brain tissue from a woman who'd passed away.
Okay.
She'd had this really unusual mental illness, major memory loss, language problems, kind of unpredictable behavior.
And what did he find when he looked at her brain under the microscope?
He saw these really distinct abnormalities. Lots of weird clumps, which we now call amyloid plaques.
Plaques, right.
And also these tangled bundles of fibers inside the nerve cells. Those are neurofibrillary tangles, or tau tangles. And what's amazing is those two things, plaques and tangles, plus the loss of connections between neurons, they're still the main physical signs we look for in Alzheimer's today.
So these plaques and tangles are messing things up in the brain. How exactly does Alzheimer's affect the brain? How does it progress?
Well, the NIA really stresses that these brain changes can actually start maybe a decade or even more before anyone notices any symptoms.
A decade, wow.
Yeah, during this really early sort of silent phase, those toxic changes are already happening. That abnormal buildup of amyloid plaques and tau tangles.
And what do these plaques and tangles actually do? What's the result of them building up?
Essentially, these abnormal proteins, they interfere with how our brain cells, the neurons, work.
Okay.
They can mess up communication between neurons. They might trigger inflammation.
Yeah.
And ultimately, they cause the neurons to stop working right, lose their connections, and eventually just die off.
Like dominoes falling.
Kind of, yeah.
Yeah.
Like damage spreading through the brain network.
And where does this damage usually start? Is there a specific spot?
It often seems to hit first in areas that are really key for making new memories, specifically the hippocampus and the entorhinal cortex.
Ah, the memory centers.
Exactly. Think of them as the brain's main inbox for new information. That's why memory problems are so often one of the very first signs.
Makes sense.
And as more neurons die off, the damage spreads to other parts of the brain. You can actually see brain shrinkage in those areas on scans.
Right.
By the time someone reaches the severe stage of Alzheimer's, the damage is pretty widespread.
That paints a clear, if sobering, picture of the physical impact. Okay, let's talk about the signs and symptoms people might actually notice. Memory problems are often first, you said.
That's right. Trouble remembering new information is often the first red flag. The NIA also talks about something called mild cognitive impairment, or MCI.
MCI, okay. What's that?
With MCI, a person has memory issues or other thinking problems that are, more than normal for their age. But, and this is key, the problems aren't bad enough yet to really interfere with their daily life or independence.
So someone with MCI might forget names more often, maybe misplace things, but they can still handle their finances, drive, cook dinner.
Pretty much, yeah. And interestingly, research is linking MCI with other subtle things too, like maybe problems with sense of smell or even slight changes in how they walk.
Huh.
But it's really important to know, having MCI doesn't automatically mean you'll get Alzheimer's.
Oh, okay.
Some people with MCI stay stable for years. Some might even get better. But it definitely increases the risk.
Are there other early signs besides memory stuff?
Yes, definitely. For some people, the first thing they notice might be trouble finding the right words when they're talking,
Uh-huh.
or maybe problems with vision or spatial awareness, like getting lost in familiar places or having trouble judging distances,
Right.
or even changes in reasoning or judgment, like making unusually poor decisions, maybe with money. So it can show up in slightly different ways.
And then NIA mentions biomarkers. What are those, and how could they help detect it early?
Biomarkers are basically biological signs of a disease we can measure.
Hmm.
For Alzheimer's, they're looking at things in brain scans, like PT scans that can actually see amyloid or tau buildup,
Wow.
or measuring protein levels in cerebrospinal fluid, from a spinal tap, or even developing blood tests.
Blood tests. That would be huge.
It would. Researchers are really pushing hard on this. Can these markers spot those really early brain changes in people with MCI, or even healthy people at higher risk?
I see.
The big hope is using these for much earlier diagnoses, maybe intervening sooner.
Mm-hmm.
But like the NIA says, we need more research to nail down how best to use them in regular clinics. They're not quite routine yet.
Got it. Promising research, but still developing. Now, Alzheimer's isn't static, it progresses. Can you walk us through the typical stages the NIA described?
Sure. Generally, they talk about three main stages: mild, moderate, and severe.
Okay.
In the mild stage, memory loss gets worse, starts impacting daily life more. Other thinking problems pop up too. This is often when people get diagnosed. So problems might include wandering or getting lost more easily, trouble handling money or bills, asking the same questions over and over,
Repetitive questioning, yeah.
taking much longer to do routine tasks, and sometimes noticeable personality or behavior changes, maybe more irritable, anxious, or withdrawn.
That sounds like a definite shift from MCI, really affecting daily function. What happens in the moderate stage?
In moderate Alzheimer's, the damage spreads further into areas controlling language, reasoning, conscious thought, even processing sensory information like recognizing faces or objects.
Okay.
So memory loss and confusion get much worse. People might struggle to recognize family or friends.
Oh, that must be so hard.
It is. They find it hard to learn new things, follow instructions with multiple steps, like getting dressed or cope with new situations. And sadly, this is also when some people might start having hallucinations, delusions, paranoia, maybe acting impulsively.
And the final stage, severe Alzheimer's. That sounds incredibly difficult.
It is. In severe Alzheimer's, the plaques and tangles are basically everywhere in the brain, and there's major brain shrinkage. People gradually lose the ability to communicate. They become completely dependent on others for everything: eating, dressing, bathing. Towards the very end, they might be bedridden as the body just starts to shut down.
It's a truly devastating progression, which of course leads to the big question. What actually causes Alzheimer's? Is it just one thing?
The NIA makes it clear, for most people, the exact causes aren't fully understood. The thinking now is that it's usually a complex mix of things unfolding over many years.
Like what sort of things?
Age-related changes in the brain, definitely. Genetics play a role. Environmental factors throughout life, and lifestyle choices too.
Right.
How much each factor contributes can really vary from person to person. It's not usually a single cause.
So a combination of vulnerabilities and maybe triggers. And what about those plaques and tangles? What's the latest research saying about them?
Well, scientists are using really advanced brain imaging now. They can actually watch these abnormal proteins, amyloid and tau, build up and spread in living people.
That's incredible.
It helps them connect the protein patterns to the cognitive decline they see. They're also digging deep at the molecular level. Why do these proteins misbehave? How exactly do they damage neurons? And there's a huge focus on the very early changes, looking for tiny signs in brain fluids or blood, maybe years before symptoms even start. All this is critical for better diagnosis and hopefully treatments that target the disease itself.
One thing that always comes up is why it hits older adults so much more often. What's the thinking on age being such a big risk factor?
Yeah, that's a central question. Research into normal brain aging is looking at how getting older might just make the brain, well, more vulnerable.
How so?
Things like gradual brain shrinkage or atrophy, increased inflammation, maybe damage to the brain's blood vessels over time, the buildup of harmful molecules called free radicals, or even problems with how brain cells produce energy mitochondrial dysfunction. Any or all of these normal aging processes might sort of lower the brain's defenses, making it easier for Alzheimer's pathology to take hold and do damage.
And genetics. You mentioned that plays a role. How big a part is it?
For most cases, the late onset type, there isn't one single Alzheimer's gene that causes it.
Okay.
Instead, the NIA explains risk is likely influenced by many genes interacting with lifestyle and environment. Variations in these genes can nudge your risk up or down. It's more about susceptibility for most people.
Are there any specific genes strongly linked to risk, though?
Oh yes, scientists have found over 80 genetic regions linked to late onset risk. But, and this is a key difference, only 3 genes are known to directly cause the disease.
Only 3.
Yeah, APP, PSEN1, and PSEN2. Mutations in these are rare, but they guarantee someone will develop Alzheimer's, usually much younger, before 65, sometimes even in their 30s or 40s. That's the early onset familial type.